So hi everybody, good afternoon and welcome to session number 7 of our series, which is network security from scratch, right? So in the last session, we discussed some of the nitty-gritties of TLS, and we saw the actual packets which were flowing over the wire, right? We also learned how to see the packets in Wireshark. But what is the agenda today? The agenda today is that we are going to learn a new protocol, and believe me, the basics are going to be absolutely same. Whatever we know now, right? Confidentiality, integrity, and authentication, we are going to use this to understand various protocols. And the new protocol which we are going to discuss is IPsec. But before coming to IPsec, right, we need to understand why we need another protocol which is providing us the same thing: confidentiality, integrity, and authentication. Believe me, to understand that piece, you need to understand basics of networking too, right? That how traffic or how a particular packet is processed at network layer. If I say layering concept, then we need to also understand at which layer your transport layer security works, or TLS or SSL works, right? So here is the agenda for today's session. We are going to discuss about TLS and its layer, and this is important in if you want to understand better a new protocol which is IPsec. Okay. Now there is a question that can we provide security at network layer? When you will be seeing the TLS is a higher layer protocol, there is a requirement to provide security at network layer, and believe me, at network layer the protocol which works is IP, and IP does not have any inherent mechanism in its header to provide the network security or the IP security, right? Then there is a need of a protocol, but before that we need to understand some of the use cases which is going to prove that yes, absolutely there is a need of a security protocol at network layer 2. And at that moment we are going to bring the concept of VPN also. At last, we will be starting looking into internet protocol security, which is IPsec. Maybe we will be touching the basics of IPsec first today and covering the nitty-gritties of IPsec maybe tomorrow. Again, to set your expectation, IPsec itself is a huge protocol which required maybe 10 to 20 hours of understanding, right? Because it's not just a one protocol, it's a suite of protocol. So to cover everything means 20 hours content in just one or 2 hours. You can think that we are going to simplify the things, but it is my promise to give you a detailed version of internet protocol security also, and I will be uploading that course soon. Maybe I will dedicate to my 10 to 15 hours along with the Ashish in creating that course, and we will upload it on SharePoint, Cisco SharePoint, or the YouTube. We will let you know. But today, tomorrow, we are going to dedicate our entire time on internet protocol security, which is the most misunderstood protocol also, right? I'm not talking about in terms of configuration, right? Configuring IPsec is too easy. We can create all those configuration command in one router. We can replicate it in another router, and it is up and running. I'm talking about the concepts behind IPsec, right? And that is where it is most misunderstood protocol. I was looking on internet for the explanation also, that if somebody is explained it well on the YouTube, but unfortunately I couldn't find the detailed version, right? So let's try to understand why this protocol is so difficult to understand. But believe me, if you have this knowledge with you, confidentiality, integrity, and authentication, and as I mentioned, anything in security or any solution you are learning, if that solution is providing you these 3 things, it is pretty easy to understand because you know the basics of it, right? We have spent pretty good amount of time in confidentiality, integrity, and authentication. We will use this knowledge to explain IPsec. Having said that, let's move towards our first board, and whatever we are going to learn here, right, it is creating the base for our IPsec, and that is why it is really, really important to understand and pay close attention to these things, right? First thing first, which layer TLS works? We have seen this packet in the Wireshark also, right? The TLS packet. What is going on? Suppose we have this computer. This computer wants to communicate to a server, maybe somewhere here on the Google, or maybe it's a Google server, or maybe something else. Maybe it's the HDFC Bank, right? This guy wants to talk to HDFC Bank and sends a hello. And before sending hello, there is a TCP handshake, right? We all know about it. But the question here is that once it starts communicating over the TLS, the endpoint is that whatever is going between this host and the HDFC Bank, it should be absolutely secure. It is going to be confidential, means the confidentiality should be there, integrity should be there, authentication should be there. And at last, the whole sole point was to share the security keys so that we can do symmetric encryption and not the asymmetric, because asymmetric was processor intensive. It is as simple as that, right? So this Chrome creates that data for you, right, which you want to encrypt using TLS or SSL. So where does TLS SSL stick? It's maybe it's an application layer, maybe it's a transport layer. So I was thinking about it. So I could think that if we can place it between application layer and transport layer somewhere, then it is making more sense, because whatever the data this Chrome browser is providing application in the application layer, we are going to encrypt it using TLS or SSL, which is the main job of TLS SSL is, right? Whatever we were doing, client hello, server hello, everything, those key exchange, right? Why we were doing? Because the whole sole point is to share the security keys from source to destination, right? Once security keys have been shared, every piece of data over the wire is encrypted. And you have seen that we couldn't even read this finished message of the SSL handshake, right? You are getting data from Chrome or the application. TLS SSL is right there. It is encrypting your data and it is passing that data to transport layer. That is why you see this TLS encrypted message, which is delivered to transport layer, and then transport layer is going to pass this data to IP layer, right? To IP, whatever is here is the data. It is going to put the source IP address, destination IP address, and whatever it needs to put in the IP header. And then it passes this to data link layer. As simple as that. Data link layer is going to provide its own header, which is the L2 header. And for data link layer, this is going to be your data, and that the physical layer, you all know what is going on, right? The whole sole point is TLS and SSL works at higher level, right? If we talk about a router and we say the router is the layer 3 device, what is the meaning of it? The meaning is that router can understand layer 3. Can it only understand layer 3? No. If I say that router is a layer 3 device, it means that it is the maximum which routers understand. It means they also understand layer 2, and they have to, because if they want to send the packet towards layer 2, then they should understand this, right? They can generate R, they can create this R, the layer 2 header. I am repeating it again. Router can generate R. Router cannot forward or they cannot take address resolution packet message from one network and pass it to another, but they can themselves generate SAR, right? It is as simple as that, right? So router, if I say they works at layer 3, it means that they understand everything below network layer. And today's routers are more complicated than this. Maybe they can understand transport or application layer traffic also. They can do the deep packet inspection also if it is required. But generally, from our networking knowledge, we understand routers works at layer 3. And what is the meaning of it? The meaning is that they are going to get the IP packet. They are going to see the IP packet and they are going to deliver it on the basis of whatever routing table they have, right? So my whole sole point is because TLS works at pretty higher level, it takes the data from the application itself, it encrypts the data and then sends it. Is there any protocol which can work at lower layer of TCP/IP model? And absolutely, there is a protocol which we call it Ipsec. But let's try to understand the use case, right? Let's try to understand how normal routing works and where we need to encrypt all these messages at the lower level also, or the lower level of protocols. Maybe we can encrypt something in network layer, right? Let's see that. Let's come to our second board where we are going to discuss about network layer and can network layer provide security. Okay, we have PCA here. It's my bad that this is PCB and the IP address may be 192.168. Maybe 20.10. These two are different networks, right? What is going to happen? This PCA wants to communicate to PCB. I am thinking that can we provide security at the network layer? So we need to understand at least the packet walk, right? How packet is moving. So simple, PC1 is going to create a packet for PC2 or PCB. The source of this packet is going to be 192.168.10.10. The destination is going to be 192.168.20.10. What I am drawing, this is my IP header, and of course, inside the IP header, we are going to have the data, right? And what is the data for IP layer? The data is TCP and plus whatever. Maybe inside we do not know what is going on, right? Maybe this is a simple ping message. This packet is going here. And of course, if we want to send it over this wire, we need to put the layer 2 header, and which we are not talking about. We are just talking about the IP packet. This IP packet reaches here. Again repeating, this IP packet reaches here, which is the default gateway. Because PCA needs to communicate to a network which is not its local network, because 10.20 is in the network which is pretty far away, right? And that is why, because it doesn't know where PCB is, and that is why it sends the packet to its default gateway. This is just the normal routing, right? Because you have configured here that if in this PC, that if you don't see the destination in your own subnet, then you need to go and forward your message to the default gateway, which is 192.168.10.1. And you presume that this default gateway is going to know about this, right? And this is your default router also. The packet reaches here. I'm just writing the packet again, but with the shorter form of IP address. The source is 10.10. The destination is 20.10. What this router is going to do, router is going to look into this routing table that this packet wants to go to 20.10 and check whether it has the routing table. And of course, it is going to have this route in the routing table. Suppose it is learning that route. But my point is, you can argue with me that this is the public network. And the public network, if you are receiving the route, those are going to be public networks. And 192.168.20.10 is your private part of the network, right? You can argue with you can argue with me that what is this private and public addresses. So I would like to let you know that this ranges of IP address 10.10 sorry 10.0.0.0/8, this network, 172.16.0.0/12, and 192.168.0.0/16. This range is the range of private IP addresses, and this range is not going to be forwarded over internet. We all know about it, right? And that is why the concept of net come into picture. And if we have here 1.1.1.1, if we have configured this IP address as 2.2.2.2.2, right? 1.1.1 and 2.2.2.2 is reachable over internet because this is the public address range. So if I want to send it, then of course I want to net it and send it, right? But try to understand, this network is not the public network. This is the normal network, no problem. And now you are sending this packet. It means that at the first place, you should have the route. And if you have the route, you are going to see the destination address in the routing table, and destination address is going to say, in the routing table is going to say that if you want to reach to network which is 20, means 192.168.20.0, you need to go to this guy. This is going to be your next hop. And then your packet is moving from here to here. Similarly, it is going to reach here, right? But here is my problem. What is going to happen if this is not the public network? Sorry, it is not the private network. Suppose it is public network. If we have two routers, right? I am just explaining you some routing. If you have two routers, if they are directly connected with each other, you can run a protocol which is known as OSPF, RIP, EIGRP, anything. And then whatever routes you have, you can exchange those routes in this routing protocol, right? Suppose router 1 contains 1.1.1.0 and you are running OSPF between these two. The only condition is that you should have these two routers directly connected with each other, right? And if you have directly connected neighbors or routers, you can run OSPF protocol and you can advertise this route into this, and the R2 is going to learn this route. How? It is going to say the route is learned via OSPF. If you want to reach 1.1.1.0, you can reach via R1, right? It is as simple as that. It's general routing, right? But here is my problem. I have private networks here, which is separated by a public network. And I cannot run OSPF between R1 and R2. And the reason is there are so many routers between, right? And the only condition over this OSPF can run, you know that these two routers should be directly connected. Although maybe the distance between R1 and R2 is maybe 500 kilometers, right? I cannot get a cable of 500 kilometers and connect them, the Ethernet cable, right? And that is why I'm using this public network, so that this guy can forward my traffic, and that is why I'm using net. But suppose your requirement is totally different. Now this network is public and you want to run routing protocol between R1 and R2 so that you can exchange these routes. Maybe this is your one branch, that is your another branch, and you want to share these routes over the internet, but you cannot run OSPF because the primary condition of OSPF is you need to connect these two routes, right? But whole sole point of this game is, suppose you can connect also. You have this link also. I will be letting you know how you are going to connect. But suppose in a case you can connect also. My problem is you are going to take this IP packet which you are receiving with from PCA. You are going to see, okay, this packet can be forwarded, but try to understand this packet is going over internet, right? And if this packet is going over internet, where is the security? You have taken, you have seen the routing table, you are forwarding it over the internet, but where, how you are going to encrypt this packet? This is the problem. No network layer is involved, sorry, no application layer is involved here at this router, right? We cannot use TLS, DTLS. What is router doing? Router is getting the IP packets, it is forwarding the IP packets, and it is forwarding the IP packets as it is. And if you see the IP header, guys, IP header of any protocol, what it's going to show? Source IP address. It is going to showcase you destination IP address, right? TTL values, version, and so many things here. But if you pay your close attention in seeing this IP header, there is no field defined there which provides security. And it's a problem. It means that you cannot provide security at the network layer, right? Because there is no field. But maybe we can develop a separate protocol itself at the network layer which can provide the security, right? We are going to talk about that protocol, but my question is, did you guys get the concept that in network layer we do not have anything which is going to provide us the security, and that is why we had to send this IP packet as it is. And one more thing, guys, right? If you change, suppose you what you are doing here is you are planning to provide security in this IP header, right? If you change something or some field of this IP header, right? Then you need to do the same change on all the routers, and the reason is otherwise these routers are not going to understand what these guys understand. These routers understand normal IP packet, right? And you are planning to build a protocol. If you change this IP packet or IP header, these routers are not going to understand what was the change. It means that you need to change entire routers of the internet, which is not the possibility, right? You can change in what you can control, right? You can change R1, you can change R2's IP header or IP, whatever you want. But if you are building a protocol also, then you need to make sure that your IP packet is going to be same, whatever it was, then it is going to add more complexity. What I'm doing here is, I am just letting you know that if there is a problem, you understand the problem, there is nothing in IP which can provide you the security, right? You cannot change the IP header also, because then you need to change everything. But there is a problem, you need to provide the security also, and if that is the case, then how you are going to do that? Maybe there is a solution, right? So this board is that you try to think from the developer side also, who were trying to solve this problem of security at the network layer, because around application layer we have already solved it through TLS and DTLS, right? Now we are thinking at lower levels that can we provide the same kind of security which we had in TLS and SSL, right? So let's have a look at it, how and what they thought of, right? Which is going to be pretty interesting thing. And I am going to explain you the concept of tunneling here. What are those tunnels? And believe me, whatever the solutions we have right now, maybe it's at ACI, in data center, or SD-Access in our LAN side or the campus side, or we have a solution SD-WAN. Everybody is doing tunneling, right? So if you understand these boards, believe me guys, there is going to be your basics for those technologies also. Okay, try to understand what I'm saying here. Again, we have two PCs, PC A, PC B. My problem is going to be same, and you should understand that if I want to run a protocol between R1 and R2, and that is IGP, means Interior Gateway Protocol, and what are those IGPs? Maybe OSPF, EIGRP, RIP, anything. If I want to run between these two routers, These router needs to be directly connected, or these routers should have feeling that these are directly connected. Now you can directly ask me, what is the meaning of feeling, Vishnu? Either these routers are connected or not. But what is the meaning of feeling? Just try to understand. I want to share this route. What is this subnet? This subnet is 192.168.10.0, right? And this subnet is 192.168.20.0. I want to advertise this subnet over public internet. Then you can argue with me, Vishnu, you cannot advertise. This is private address range, right? And here is the solution. Wouldn't it be nice that if I can able to connect this R1 to R2 over some virtual kind of a link? Then you must be thinking, what is this virtual link? What is actually this? Right? So actually what is going on here is that if I have a connectivity, just wait a minute guys. I should stop it. Okay. Yeah, it's gone. So what I'm showcasing here that you can run OSPF if you have the direct connectivity or if you have the feeling of the connectivity, right? So what I'm doing here is I'm creating a virtual link or virtual circuit between R1 and R2. And how I can do that? I can do that. This virtual circuit has only one requirement. It is saying that I can give R1 and R2 a feeling that they are directly connected over me. If you can provide me connectivity between this 1.1.1.1 and 2.2.2.2. And we all know that we have the connectivity between these. These are the public addresses which are connected over the public network, right? No issues. And believe me, if you have the connectivity between these two IP addresses, a technology which is known as generic routing encapsulation can give you this virtual circuit, which is going to give the feeling that R1 and R2 is directly connected. And this is what OSPF needed, right? OSPF needed that these two guys should be directly connected, and that is why what we can do is now instead of giving IP address, basically we can give the IP address on this tunnel, and we are saying this is tunnel 0, this is also tunnel 0. It is as good as your interface because this is kind of a link, although this is a virtual, right? And I can specify the IP address here. Maybe now you can specify IP address 10.10.10.1 and here 10.10.10.2. And believe me, if you guys ping from 10.10.10.1 to 10.10.10.2, it is going to ping. And these are part of the same subnet. And if the tunnel is part of the same subnet, you can run OSPF. And if you can run OSPF, you can advertise this subnet into the OSPF. What is going to happen at R2? R2 will be learning this route 192.168.10.0 can be reachable via 10.10.10.1, which is this router, right? Or the interface of the virtual router. And how you are going to learn this route? This route is going to learn via OSPF. It is simple, right? Similarly, you can advertise this route here in OSPF, and this router is going to learn that if you want to reach 192.168.20.0, you can reach it via R2. R2 is this interface, which is your tunnel interface, right? Which is 10.10.10.2. Now, it is interesting to see the packet walk. And believe me, guys, if you can understand this, we are more closer to understanding IPsec. Then, if we understand this form, then basically we just need to apply confidentiality, integrity, and authentication on top of it, and you will be amazed to see that you have learned IPsec, right? A special form of IPsec. Let's do a packet walk. We want to spend some good amount of time in this board, so be with me. How your packet is going to look. At the end of the day, this host doesn't know anything about it, what tunneling, what virtual circuit you are doing. at router. It doesn't care, right? It is simple host. It wants to talk to 10.20. It is creating the packet that here is my source packet 192.168.10.10. The destination is going to be 192.168.20.10, right? No problem. This is your IP packet. Now, what is going to happen? Same thing, it is going to forward this packet to its default gateway. Default gateway is now having the right towards 20.0. And here is the interesting thing. It is saying that if you want to reach to 192.168.20.0, you can go and reach it via 10.10.10.2, which is something here. But what is this 10.10.10.2? This is the IP address configured on the virtual circuit, which is not there at all, right? Does that mean I cannot send the packet? No, you can, because at the end of the day, this 10.10.10.2 is configured on 2.2.2.2. It is as good as saying that if there is a tree, right? And there is a branch of this tree, and if you are sitting here on this branch, right? So basically, if this branch is there, you are there, right? If this branch is not there, nothing is there. It means that how we were able to make this virtual circuit, because there is a underlying network, which is the connectivity between 1.1.1.1 and 2.2.2.2, right? This is your branch, and this is what we call as underlay, guys. So your public network is actually your underlay here, right? And you are sitting, this tunnel is actually you. This tunnel is not going to be there if this underlay is not there, right? And whatever you are building on top of it, this is your overlay. And the technology is known as generic routing encapsulation, GRE. So what is going on, guys? This is the packet which is generated by it, and now we are adding some more information on top of it, which is something, a GRE. See, if we put some information, it means that we are putting a header. It means that it is adding value when the packet reaches to the destination, right? And now here is the trick. The trick is actually we are taking this packet and we are making this packet as a data. This is not more the IP packet for us. And what we are doing is we are encapsulating, or we are putting it into a bigger IP packet. And this bigger IP packet is having, again, source IP and destination IP, right? And whatever the packet generated by this PCA along with this GRE header, what is that? This is only data. Data for what? This is the data for outer packet. And you will be quite sure to know that source IP of this packet is going to be 1.1.1.1 and destination is going to be 2.2.2.2. Then you are going to say, wait a minute, Vishnu. You have the route which says that if you want to reach to PCB, you need to go to this guy, 10.10.10.2, and you are sending the packet to 2.2.2.2. What is 10.10.10.2? It is a virtual, it is nothing, right? But you know that it is configured on 2.2.2.2, right? So it means that there is a corresponding packet. Just wait a minute, guys. There's a little bit disturbance in terms of these WhatsApp messages. Okay. So here you go. 10.10.10.2 is nothing, right? It's a virtual IP address which is configured on this. So we are sending on the actual IP address, because at the end of the day, packet is going over this branch, which is the branch of the tree, right? The underlay. Right? What is going to happen now when this packet moves and reaches here, 2.2.2.2, right? It is going to, and by the way, guys, there is no change in the IP packet, and the reason is because to all these routers, what they are seeing the outer IP packet, and you haven't changed it, right? For outer IP packet, whatever is inside, it's the data, but we know that inside it, it's a GRE technology. So all these routers are going to see that the destination is going to be 2.2.2.2, and they know how to forward it. This guy is forwarding like this. This router again see in the routing table and check where is 2.2.2.2. It is going to forward like this, and then basically we are moving here. When this packet reaches to R2, it is going to check what is the destination. It is seeing the destination is me only. But then it checks the IP header. In IP header, it is written in the protocol field that the next thing which you are going to see is GRE. Then router 2 comes to know that this is not the normal IP packet, right? It is something inside it. And when it sees GRE, it says that it is going to, of course, it is going to remove the outer IP packet. It is going to see the GRE. It is going to remove the GRE header also. And then it is going to see this packet. And this was the packet which was sent by this host in green color, right? This packet is going to reach here, and this router is going to forward it to the destination. Very simple, right? But if I may ask you that I am saying that there is a virtual circuit or this tunnel, is this tunnel really there? Because we always say people that there is a tunnel, GRE is a tunnel. What is the meaning of this tunnel? The meaning of this tunnel is actually this tunnel is not there at all. What you are doing, you are just encapsulating an IP packet inside another IP packet, and that is it. But yes, to visualize, to think that how it is working, the tunnel analogy is absolutely correct, right? But when something comes in your mind with respect to tunnel, believe me guys, this is not a tunnel. This is just you are encapsulating something into IP. And that is why I have written here IP in IP. You have the IP packet, you cannot send it directly because of the IP addressing, right? And that is why what you are doing, you are encapsulating in that IP packet which can forward it, right? But in doing so, you need to inform router R2 that whatever you are seeing as IP packet, do not take it literally as IP packet, because inside this IP packet, there is another IP packet. How to inform this router? And that is why you have included in this GRE header, right? This GRE says that Mr. R2, do not treat me as a normal IP packet. Don't dare to do this, right? Because I am not normal. I am a GRE packet, and the actual IP packet is attached with me. And that actual IP packet you can see in the green color. Maybe these things are overwhelming to you if you only belong to security, but these things are okay to you if you are a network engineer or network consultant, right? But why I am explaining this IP and IP? And the reason is I want to explain you the concept of tunnels. Now, it is absolutely clear that we can send a private IP packet over public network, and we can give it the feeling of also that OSPF, that these R1 and R2 are connected through GRE, right? We can run routing protocol, right? But here is my problem. Again, where is the security? Vishnu, you showed us a problem that previously we couldn't able to do share the packet because of private address range. Then you showed us that we can create a tunnel. That is fantastic. Then you informed we can run OSPF also. That is fine. Then you show that we can share the route also through OSPF, and then you showcase us that how this packet is going. But in the whole thing, we couldn't see the security, and that is the problem, guys, which we are going to solve. What if I say that I can provide the security, and the security where it needs to be there, the security needs to be there whatever this packet this guy is sending to this guy, right? And what is that? That is the green packet, right? What if now if I can encrypt the packet, right? And instead of sending GRE, I say some more information that how to decrypt this message. Then we can provide the security also, right? And the outer packet which is going over these internet router doesn't need to worry about what is going on inside, right? Whether it is encrypted, not encrypted. But yes, it is for sure that if the intruder is there, if he sees the packet, if it sees the inside packet also, it is not going to understand anything because now the packet is encrypted, right? Try to understand the order, right? Previously, the problem was I was not able to send the packet, right? Then we bring the GRE technology. In GRE, what we are doing, we are taking an IP packet. This packet is uh, encapsulated in another IP packet. That is again fine. But what is the problem with that? No security is there. How we are going to provide the security? What we are doing now, we are just encrypting the inner part of the packet. If we can do that through any way, then my problem is solved. Because outer packet is normal. It can be understood by anybody. And it should be because this is going over the internet, right? But now the inner packet is encrypted. But the now question arises that how we are going to encrypt it, right? But before that, I would like to explain you one more concept. Whatever we have discussed here, actually that is your VPN, a specific type of VPN, which we call as site-to-site VPN. Do not worry, guys, we are going to take your questions exactly at 3 p.m. I will be stopping this, right? But try to understand what I'm saying here. Now you understand that tunneling is there. There is a tunnel which I was showcasing you, right? And that is the virtual tunnel that is not exactly there. But in real, what is going on? IP packet inside IP packet. And here is the problem now. And let's see whatever we have learned today. Can we solve this problem? We have two branches, right? We have one Delhi branch here, right here. And we have branch at Bangalore. Now what I want to do, I want to connect these two branches, and the connectivity I have taken is the public internet. This is my public network, which is internet, right? And the problem here is that we have a lot of intruders here. You can straight away say that I can solve at least one problem now. What? That I can create a tunnel between this R1 and R2 so that actually at least you can send the packets, right? And what is that tunnel? GRE. I'm going to say, okay, at least first part of the problem is solved. At least I can connect my Delhi branch to my Bangalore branch. No problem with that, right? Through this GRE. And what I need to do now is, what this router need to do is, whatever the packet these laptops or these PCs are going to send to him, what it is going to do, it is take that packet, IP packet, it is going to put a GRE header on top of it, and then it is going to encapsulate this packet into the bigger IP packet with source of 1.1.1.1 and destination is going to be 2.2.2.2. As simple as that. No router in the middle is going to complain because for them it is an IP packet. No issues, no problem. But now, because this is company's branch, guys, you do not want to send packets in plain, right? Although the packet which is generated by these laptop is inside the outer IP packet, but everything is plain, right? Everything is plain text. What do you guys need to do now? The requirement is not only to connect your Delhi branch with Bangalore branch, to connect them securely. And you have given this responsibility to these two routers, router number 1 and router number 2. And if this tunnel, whatever you are doing, can provide the connectivity plus security, then your problem is solved. What if I can run a protocol on this GRE which is making this inside packet secure as we discussed, right? So if you want to create, or if you want to make this IP packet secure. We understand the basics of security now, right? What are those basics? Those basics are confidentiality, integrity, and authentication. If through any means, if I can provide confidentiality to this inner packet, integrity to this inner packet, authentication of the between these two hosts, then I can surely say that the second requirement of security can also be met, because this intruder cannot read the message if I provide CIA, right? And finally, the end of the day, the goal is that if this router R1 and R2 can share the secret key with them, right? Then they can do symmetric encryption, right? Which is the encryption which is loved by processors, right? So if you talk about whatever we have read in last 6 sessions, so guys, are you able to hear me? Ashish, can you hear me? The audio is good. Can anybody confirm, please? Okay. Okay, I could see. So I was perfect. So what I was informing you is what I was discussing with you is that of course that the whole sole point of those SSL and the thing which we were discussing in last 6 session is that if we can share this secret key so that we can finally do the symmetric encryption. And here is the goal also, by any means R1 can authenticate R2, first thing, right? And if they can exchange the security, or if they can exchange the secure key, then it is done, right? Then what R1 is going to do, that it is going to encrypt the inner piece of the packet and it sends it. It is as simple as that. And believe me, that is what your IPsec, IP security protocol, is designed to do, right? So I know that we are pretty slow in learning IPsec, because after 50 minutes, I have taken the name of IPsec, that why we need it. But believe me, that was required. At least this much detail is required to understand that why do we need IPsec. And still, I have covered only a specific piece of IPsec, which is tunnel mode of IPsec, right? Where we are doing tunneling. If we want to connect two different sites securely over an unsecure medium, guys, I am not talking about single computers now. I am talking about two different sites, and these sites can have 500 devices here as well as here. But now the routers are coming into picture, because all the traffic of these devices passing through these routers, right? And we are performing encryption or CIA or the security over these routers, right? So it doesn't matter if you put 500 computers or 800 computers, at the end of the day, the traffic is going to be on these routers, and routers can encrypt that, and then the receiving router can decrypt it. It is as simple as that. So by the way, guys, whatever we are seeing here, if this is providing security, we call it as IPsec tunnel, and the entire thing is known as site-to-site VPNs, because you are connecting two sites. Now I'm not saying that you can only connect two sites. If you have thousands of sites, you can do that. Even believe me, your SD-WAN solution does that. It creates these IPsec secure tunnels with every branch in a full meshed environment, right? But we are going to understand here what is this tunnel, how we are providing security here, right? Tunnel portion we are pretty much comfortable with now, no problems, right? What is the problem? The problem is how we are going to secure it, and for that we are having here internet protocol security. And believe me, guys, this is not just the one protocol. So what we are doing here is, see, if the packet comes to this network layer, We have network layer, we have uh, data link layer, we have application layer, right? And consider this as a router. Router understands 3 network means still layer 3. Just try to, and if this router receives an IP packet here, right? My goal is then when this packet goes out of this router, right? Doesn't matter if you are providing tunneling or anything else. If it goes out from this router, it should be encrypted. It should be secured by any means, right? And which protocol is doing this at network layer? We have implemented along with IP, security in IP, which is Ipsec. And of course, if it is providing security, it is doing the same thing: confidentiality, integrity, and authentication. So Ipsec protocol is not just one protocol, it is a suite of protocol, right? If I talk about Ipsec, it has two different things. I'm not a big fan of uh, terminology, but I have to include it. But if you don't understand it, believe me, we are going to cover it tomorrow, everything. So Ipsec works as with two modes. One is authentication header, another with ESP. But the whole soul, but the end point is it is going to provide you three things: encryption, which is your confidentiality; integrity and authentication, right? It means that CIA is done. And there, basically, we were able to exchange the key using RSA, public key, right? In SSL. Here we have another piece, another beautiful algorithm, which is known as Diffie-Hellman. So instead of, because at the end of the day, I'm again repeating the same thing. The goal of the security, whatever we are doing here, right? It should be like at the end of the day, we need to perform symmetric encryption. And for symmetric encryption, we need keys. Keys at source and the same key at the destination, right? In SSL, who was doing that in the form of in the form of exchanging that pre-master secret? We were doing it by encrypting it using public key of the server, right? So that it and only it can decrypt it. But here we are using RSA for or the public key or private key for authentication and integrity, and encryption for providing confidentiality. But for doing that key exchange, we are not using this RSA. As I mentioned, that we are using here Diffie-Hellman, which is considered to be more secure than RSA. Right? Again, the algorithms are going to be same. In encryption, we are going to use AES-DES. Again, for the authentication and integrity, we are going to use RSA, MD5, and for authentication part, it is RSA, right? For this, it is SHA. For Diffie-Hellman, we have Diffie-Hellman group number 1, or maybe 2, maybe 5. We will be studying about, we will be going to learn about it, right? But as you can see that it is not a single protocol. So there are so many things in Ipsec, but we will try to simplify everything for you. But at the end of the day, the goal is, if I talk about tunnel mode or of Ipsec, that at the end of the day, the goal is that if we have this router 1, if we have this router 2, which are far from each other, maybe 1000 kilometers, the goal is that if this router gets the IP packet here at the network layer, this IP packet should go into this network. Maybe let me draw it with the green color. Internet, right? This IP packet should go over the internet, which is encrypted using symmetric encryption, right? So that no intruder can read it. When it reaches here in the encrypted format, this guy should be able to decrypt it, right? And it should get the normal IP packet so that it can forward it. And maybe we can have the direct tunnel between them. And that tunnel is just nothing because you cannot change any form of the IP packet which is you are getting. So it will be encapsulated in the bigger IP packet. And you are going to put a header here which is going to give you information how to decrypt the packet which is inside here, right? And we call this as Ipsec header. As you all know, what are those headers? Headers are giving you the information at the receiver side how to decrypt this packet, right? So how a typical IP packet is going to look, right? When it goes into this router R1, suppose this is the packet, it is going to contain source IP, it is going to contain destination IP. Now the whole sole responsibility of R1 is, and I am making sure that this R1 is instructed to do IPsec to secure your messages. If it is the case, then what it is going to do is it is going to put a IPsec header on top of it. Now this complete thing is going to be data for what? For outer IP packet. It means that outer IP packet is going to, let me draw it with some other color, maybe blue color. So outer IP packet, we are going to have this. Source IP is going to be this interface, maybe it is 1.1.1.1, and destination IP address is going to be this interface, which is maybe 2.2.2.2. So at the end, the packet which is flowing over internet, right? You see this. And because this is IPsec, all the information you have placed it here to decrypt the message. And yeah, whatever you are seeing here, this is encrypted form of the message. This entire packet goes, right, over this wire. You can argue with me that Vishnu, the IP packet length, the IP packet can take only 1500 bytes of information, which is its maximum limit, right? I agree with you, this is the case. And then we put an IP header on top of it. But still, it can take the data of 1500 bytes, right? But now here is my problem. If I include, see, data was 1500 bytes, suppose. And if I say I'm doing IPsec, then this length should be something, right? Maybe this length is maybe 20 bytes or 10 bytes. Take an example. I'll let you know the exact IPsec header length. But let's take an example. Now, this is a problem, right? Now the entire length is going to be 1510. And outer packet can take only 1500 bytes of data. So what you need to do, and that is where basically you need to reduce whatever you are getting. You need to make sure that whatever everybody is sending, it is sending almost 1490, right? If everybody sends 1490, then 10 bytes for your IPsec, it is going to combine as 1500, and then basically it can be encapsulated in outer packet. This is what we call as IPMTU, which you can change. Right? If you didn't get that, whatever I said in last 30 seconds, do not worry about it. But you need to understand that at the end of the day, what we are doing is we are just encrypting the IP packet at IP layer. And that is why we need another protocol, which is IPsec. And that is why we are adding header, so that at the destination can decrypt it, right? But here is the thing, how we are going to encrypt it, because if we want to encrypt it, we need to understand that we are going to use AES or DES, right? If we want to do hashing, we need to understand that we are doing either SHA. If we want to authenticate, maybe we are using RSA. If we are doing key exchange, maybe we are using Diffie-Hellman here. This R1 understand this, right? That he needs to do this. But how it is going to inform Mr. R2, I want to do these things with you, so that you can understand at the receiving side that you are using AES, SHA, RSA. It means that before doing any encryption, these guys talk, R1 and R2, that boss, I am using this algorithm for encryption. I am using SHA for something else. I'm using RSA for authentication and I'm using Diffie-Hellman for my key exchange. It means that to begin with, before any encryption, these devices needs to communicate, right? To share all these values, to share the secret keys and everything. And that is where your IPsec protocol come into picture. IPsec take the services of few other protocols which we known as ISA KMP, right? And where basically IKE is going to come into picture. Too many terminology, but we need to deal with it, right? But at the end of the day, you understand the problem. We need to encrypt the packet, and if we want to encrypt the packet, or if we want to send the packet, we need CIA. If we need CIA, we need any mechanism through which R2 can know that what R1 wants to do, right? Similar thing, like Anjali is talking to HDFC Bank. Anjali is saying in the initial hello, I want to do AES with you. I want to do SHA with you, right? Here is my cipher suite, right? We need to exchange the cipher suite information, right? IPsec has its own way of doing it. SSL had its own way of doing it, right? We need to understand both of them. So tomorrow's class, we are going to discuss a little bit deeper. We are going to go a little bit deeper, but the whole sole agenda or the point is same, that how these guys are going to do the CIA. Confidentiality, integrity, and authentication. This is the basic, guys, okay? Just like we understand SSL, TLS, hello messages and everything, we are going to see exactly this in IPsec also. Having said that, this is what I wanted to explain in today's class. I am open for questions now. Please go ahead for your questions. It is good that we do not have any questions today. Perfect.
Hi Vishnu, Ankit this side.
Hi Ankit, please go ahead.
Actually, for if you are using public network to transport our data, right? So we need to use GRE as you told, right? To
Yes.
transport the IP packet.
If you do not want to do NAT.
Yes.
Yep.
Okay. Or if we are using our ISP, means we are using our network, right? So we did not require that GRE, right? Only IPsec will be required. Means
Only
GRE.
you can say that.
Okay.
Yes, yes, you can say that. Means basically we do not require the tunneling.
Right. So IPsec will be enough, right? In our network, private network we are using.
But generally, believe me, if that is your private network, then basically there is no use case. For example, this is your private network, suppose, right? And you have one laptop here, one laptop here. Okay, you want to say that basically if you want to encrypt the IP packet, then what we need to do, right?
Yes.
Then basically you can create an IPsec tunnel between these two hosts itself and do that. We can do that. But we were discussing pretty specific case.
Okay.
This is not your tunnel mode. This is your a different mode. I will let you know tomorrow. Okay.
Okay. Thank you.
Yeah, hi Vishnu.
Yeah, please go ahead. What is your name, please?
So, yeah, this is Murali.
Yeah, Murali, please go ahead.
Yeah, so the GRE is a kind of non-secure tunnel and IPsec is a secure tunnel.
You are right. GRE is basically your IP in IP. You are taking the plain IP packet, you are encapsulating that IP packet into the bigger IP packet and you are sending it. That is it.
Okay.
But IPsec is encrypting that inner packet and sending it.
Hi Vishnu, Sainath here.
Yes, Ainatji, please go ahead.
So even with the IPsec also, our old security, whatever we have done in the TLS, that is going to be there, right? Still?
No. TLS is having the different altogether use case. As that is what I'm saying, that now we are talking about routers. Previously, we were talking about this laptop, right? This laptop was want to talk to HDFC Bank, and that is where the security was at application layer, right? Now I'm talking about how you are going to connect to different routers securely. And if you can connect them securely, whatever is connected to these router, maybe 100 hosts, 200 hosts, doesn't matter. Here, this was the
Now, if
responsibility of the laptop.
Anjali wants to connect to the SDFC server,
Mhm.
end of the in between there are definitely there will be lot of routers will be there.
Yeah.
Now all these routers security we are talking about, these IPsec are that is not the
Yeah.
case.
So see, it's a good question actually, and we need to clear that doubt. Suppose we are sitting in our branch. Maybe we are in Delhi branch sitting, right? And Delhi branch is going to have the router also, which is connected to internet. And on internet, we have HDFC Bank. Let's try to understand. This is very, very good question actually, which is going to differentiate between these two technology, right? We have this Delhi branch. And now we are sitting inside the office with our laptop. Very good, no problem at all. This is my laptop. And this is Anjali's laptop, wants to talk to HDFC Bank, right? When she is doing it, right, she is going to go via this router, of course. She is sending the hello. She is receiving the hello. She encrypt all the parameters and no problem. Again, to the router itself, it is going to see only IP packet, right? Because everything, whatever Anjali is doing, is after TCP, and even after TCP, we have the TLS packet, which is encrypting all the data. Although this router is not going to understand anything, right? Because everything is encrypted. But try to understand, for router, it is just the IP packet, it has forwarded it, no problems. But now the question is, if you have another branch also, right, somewhere in the Delhi, sorry, somewhere in the Bangalore here, which you have connected through a router. Let's take the pen. This router, right? Okay. It's getting the mess. We have this router again, router 2 suppose, and this is again connected over the internet, the same internet, right? So if you are having a server here, maybe a server here, which is B, and if you are, nobody is doing IPsec also. If Anjali wants to communicate to this guy B, she can do the TLS. No problem with respect to that. She can do the TLS. She can go and communicate to this guy. Okay. She can create the TLS and it is going to be secure as whatever I am saying. What I am saying is that there is another technology which is at IP layer, which is IPsec. What this technology is doing is, we have internet, again we have router, and then we are having so many devices here. I am saying that these devices, no need to worry about security at all, because you are saying that this is not your responsibility to be secure, right? We are, as an enterprise, we are providing you security over this internet by providing this tunnel to you, which is secure, right? So all the traffic, whatever going on, and by the way, the connection between your branches, it not going to be only TLS or application based, right? It can be anything else. So now here on this router, you are providing the security over this IP by encapsulating it into, right? But yes, you can argue with me that we do not need this IPsec tunnel at all if we are running a server here and this guy is communicating directly to this server over TLS. Of course, this is already secure. But generally,
Okay, it's clear now.
this is
Okay.
clear now. Perfect.
And so this IPsec we can do only in case of this source and router.
No, this is the one form.
In our control.
Yes, you are right. But there is another form. Means it is not the case that we can only make site-to-site VPNs with IPsec. It can work like remote access VPN, because if you understand any connect, right, which I am going to include in tomorrow's session, I believe. If you see that it can do IPsec also, by the way, right, and it can build your remote access VPN. And let's leave it. Let's not, because I haven't discussed it. Tomorrow we are going to take it. But you understood
Thank
it well.
Yes, understood.
Anybody else, guys?
Vishnu,
Mm-hmm.
I wish you Sandeep Lamba this side.
Sandeep ji, yes, please.
Yeah, Vishnu, my question is, so now it is, now we can say that the IPsec is worked on the network layer and the SSL is working on the application layer.
You can say that, but actually there are some initial packet of IPsec which we use, which we are going to discuss tomorrow, which go over UDP to for the net traversal. Means there are some nitty-gritties which we can say, but mostly yes, the IPsec is going to work at the network layer. You are right.
And the SSL is on application layer.
You can say that between application and transport. You can say
Uh, there is a no specific layer or
there is
between
no. So I was thinking that how to make it clear to you guys, right? That how we can do that. So the uh, most basic thing which I could think of is this one, that is going to take that packet, and it is not the case that every layer is going to work at a specific layer. No, you cannot differentiate sometimes, right? And I will give you the example of address resolution protocol. People say it is the protocol which work at layer 2. I don't agree, because if you just open the packet of ARP, it contains IP address information also, right? So we call it as layer 2, means somewhere in the middle between 2 to 3. But at the end of the day, these layers are just there for your understanding, right? And that is why for your understanding, I have drawn this TLS SSL more towards application layer and less towards transport. But at the end of the day, it is taking the data, right, from the application, it passing the data to transport, and it is doing its magic here, right? Encryption and all.
And one more question,
Mhm.
is there any difference between SSL connection and SSL VPN?
SSL connection, no, it is same. But yes, there are two things. Means what VPN you are making, right? Generally, if it's a there are two types of VPN. One is remote access, and we can do SSL there also. But actually, we are asking a lot of questions from tomorrow's session. So let's go
Okay,
through tomorrow's session,
that's
and
right.
then probably we can see that. Okay.
Yes, sure. Thank you.
Anybody else?
Vishnu,
Yes, please go ahead.
Vishnu, can we run OSPF or EIGRP in between the IPsec
Yes, yes, we can. Yes, we can.
without GRE?
Uh, at the end of the day, basically, mostly we run IPsec over GRE. In case
No,
of, yeah,
actually, we have possibility, right? Like we can only run IPsec.
yeah, we
Am
can
I
only
correct?
run IPsec
Uh,
also. You are right.
with OSPF, can we? Is it work? OSPF work on that way?
If there is a link, see, if you have generally we create GRE, and for that reason that it is giving us the link like feeling, right? Then we can configure the IP address over this tunnel. I need to check whether we can configure the same for only IPsec tunnel or not. Okay.
Yeah. Okay.
Yeah. Anybody else?
Yeah, hi Vishnu. So
Name
IPsec
please. Name
over
please. Name please.
Mohit here.
Mohit ji, yes.
Mohit here. Yeah. So IPsec over GRE means, I mean, basically going to have a tunnel IP, outer IP will be same, right? IP header will be same, right?
We will be letting you know this tomorrow. There are
Okay.
some more information to come. But it's a great question actually. Don't worry, we'll let you know tomorrow. Because what I did in today's class is just I introduce IPsec, right? We just made the basic, and that is why the clarity is not there. But do try to attend tomorrow's session, and your doubts will be clear.
Okay.
Okay, Mohit? Yeah, please go ahead. Anybody else? I think we are good. So it was wonderful meeting you guys once again, and have a nice day. Let's meet tomorrow, the Friday, and let's try to finish this IPsec so that we can move to next phases of this training, which you want to see something in action with ASA, Identity Services Engine, and then Umbrella, right? And Ashish is going to help us pretty soon. Thank you so much once again. See you tomorrow. Bye for now.